Right. So this formula, which stems from the theory of relativity by Albert Einstein, which takes it a step much higher than what Newton, suggested, that time is constant for all observers, but in reality, time is not constant for all observers. This formula has been proven. T, where T is the time of the stationary person, so that's for the stationary T off. So you put a bracket there. You can put off, a bracket is off, of stationary observer. Relative, because two objects moving, one can be considered stationary and the other one moving relative to, although both of them could be moving at different velocities. Okay, so so let's consider that person to be stationary relative to this, person who is in motion. Okay, the times are different. U is the velocity of the moving object and c is the speed of light. So take, for example, u is equal, let's say someone is traveling very, very quickly, 0.95 the speed of light. 0.95 the speed of light, whatever the speed of light is. What's the speed of light? Anybody can share with us what is the speed of light? At what speed does light photons travel? Anybody? If you can remember, just Google it one time. I'm waiting for the answer. Anybody? Please Google what is the speed of light. It doesn't matter, you can put in meters per second or kilometers per second. 300 million meters per second, or sometimes I know that's 3 times 10 to the 8 meters per second. That is the speed of light. And according to Albert Einstein and the theory of relativity and a lot of experiments, that is the maximum speed that can be attained by any particle in our universe. Okay, and physicists will try to debate that constant, but so far it holds that the speed of light is the maximum speed that can be attained by any moving object and in our known universe, in our reality. So let's presume that there's an object who is traveling very fast. It could be a subparticle, 0.95 the speed of light. Okay, that's the velocity it has, and we know the speed of light is c. Okay, one is 1 and t is motion. Let us say that the stationary observer, someone who is stationary relative to the moving person. Let's say they observe that object for 2 seconds. The time is 2 seconds. So when they watch their clock, the time is 2 seconds. How long? Okay, what is the time? What is the time for the person who is moving? Okay. What will be the time for the object that is moving? No. We are solving for the t motion, t of motion. So therefore now, little transposition, we're going to make t of motion the subject of the formula. Okay, a little bit of transposition. So let's just copy this. Let's just paste this, centralize this. Okay, activate it. So we're solving for t of motion. Okay. So t of motion, cut this, put this there, is equal to, so we put back t of motion there. To cancel this out, we have to multiply that whole thing there by that. Okay. We're going to put that in a bracket. So that whole denominator there, and close that in a bracket, in a basket. Okay. Multiply 2. Okay, because to cancel this out. Okay, let me just show you. Okay, it's a little revision of transposition. That's a very important algebra skill to learn. Okay, no matter what subject, be physics, biology, agriculture, economics, making the subject of the formula is a very important, because you know you might have an unknown and you want to solve for an unknown and you want to use a formula. Sometimes the unknown you want is not the subject. So you have to rearrange the equation to make the subject, and this is a very important skill. We know the t, stationary, we know the u, we know c, we know 1. We want to find t, so we're going to make t the subject. We're going to cancel this whole denominator by multiplying. Okay. What you do on the right, you do on the left. Okay. So what will happen now? This multiplication there will cancel out that division. Okay, this multiplication will cancel out this division, and then you are left with this now, and you can read from left to right or right to left. So t of motion is equal to, okay, t of motion is equal to, you can read from right to left, you can read from left to right. So t of motion is equal to, okay. That's what we want to solve for. T of motion is equal to, okay. So therefore, we're going to substitute now. So now we know how to find t of motion. Now we know how to find t of motion. The values for t of stationary, we have it as 2 seconds, and u, we have it as 0.95. 0.95 c and 2. 0.95 c and 2. So in the place of t of stationary, we have to substitute 2. So let's do that there. 2 times the square root of yes, come on, 2 times. Okay, let's just copy this. 2 times the square root of all right. Okay. U is 0.95 C. Okay. So what will happen now? The C squared is going to cancel out. C squared divided by C squared. Okay. Yes, so C squared cancel out. What we are left with is 1 minus 0.95, the square root thereof. So what we are left with is the square root of, okay, 1 minus 0.95. And this can be easily calculated. With all this is, you know, we can easily calculate 2 times 1 minus the square root of 95. Can somebody please calculate 2 times 1 minus the square root of 0.95 one time in your calculator? 2 times the square root of 1 minus 0.95. As is, just put that straight up in your calculator. You don't really have to step by step minus 0.95 from 1 square root and then multiply by 2. Your scientific calculator should be able to put that straight off in your scientific calculator. 2 times 1 minus the square root of 0.95. See what you get? Two times the square root of 1 minus 0.95. Okay. 0.447 seconds. 0.447 seconds. So therefore now, whilst the stationary observer is measuring 2 seconds on their clock, the observer who is in motion, their clock is registering 0.447 seconds. Okay, so bear that in mind. Okay, so hence stationary observer, okay, stationary observer's clock is 2 seconds whilst the observer's clock is 0.44 seconds. Reality, that's real, that can be proven. Okay, so please make this formula second nature to you, just like how F is equal to ma, this formula there, please make it second nature, like any normal formula.